We'll show you the night sky. How do we do this? Well, we actually open up the roof. No, of course we don't. We use this device here in the center of the room, our star projector. Konika Minota. And it is with this device that we'll be able to recreate the night sky above our heads. Now, before we begin, does anyone here have a cell phone? Yeah, like I'm going to believe that one. Very well. Take out the cell phones you don't have and turn them on, please.
Oh, wow.
Now, if we look at the screen above our heads, we can see that our cell phones are creating light pollution. It's a bit like when we go out in our backyard at night to look at the night sky. We see a handful of stars, and everything else is lost in the glare of city lights. Now, is this what we want to see during our show? No. Obviously not. So everyone, turn off your cell phones.
Dude, turn them off.
This is the sky above Montreal. That's my supervisor telling me to get on with it. Is this what you see when you look up at your night sky? And why not? Light pollution. Now, you may not know this, but the city of Montreal spends $15 million every year on outdoor lighting. A third of that, $5 million, is light going up directly or indirectly into the sky. Apparently, we have loads of energy and loads of money to waste. Now, for those of you who didn't recognize it, this is the Milky Way. I mentioned this because most people born after 1950 have never seen the Milky Way in their night sky. Now, when we see a sky like this, we need to orient ourselves. So what do we use to orient ourselves? What's our compass in the night sky? Polaris and North Star. Okay, everyone point to Polaris. No, you're pointing in the wrong direction. So how do we find the North Star? The Big Dipper. Now, a word of caution here. If you ever go out in the countryside, very far away from the city, to see a sky like this, you won't see white lines in the sky. That's extra. Now, Big Dipper here, is that a constellation? Yes. No. But it's part of one. Ursa Major, the Great Bear. Now, how do we find a North Star? Well, we take the two stars of that container opposite the handle, We draw a line through them and we go straight up. That takes us to Polaris, the North Star. Polaris represents the tip of the handle of the Little Dipper, or the tip of the tail of Ursa Minor, the little bear. Immediately above our heads, we see three bright stars forming the summer triangle. Everyone sees that?
Oh, yeah.
You see it now. Really good. Is this a constellation? No. The three stars, in fact, belong to three different constellations. Vega is in Lara the Harp. Deneb is in Cygnus the Swan. Altair is in Aquila the Eagle. Now if we keep going east, we'll see a square, a big square in the sky. Shaped like a diamond, really. Everyone sees that?
Oh, there.
It's called Pegasus Square. Three of these stars actually belong to Pegasus. The other one belongs to the Andromeda constellation. Now you may have noticed that Pegasus is only the front portion of a horse in the sky. Why is that? Well, the story goes like this. When Pegasus died, the gods wanted to reward him for his good deeds. So they put him out in the sky as a constellation. He proved to be too large. So they cut the horse in half. And they left a front portion in the sky. The other portion fell down to earth and created a race of humans we call politicians. Well, we'll end our sky show on that note, ladies and gentlemen. Now, before we move on to the next part, Aurora, has anyone here ever seen the Northern Lights? Those of you who did see the Northern Lights, where did you see them? Alaska? Nova Scotia? Okay. Anyone ever seen the Southern Lights? That means you were in Australia or New Zealand or Argentina. Okay. What color were these lights when you saw them? Well, that's the most common color. I'm sorry? Okay. You need to stop drinking. Just a joke. Red, you do see red Northern Lights, but they're fairly rare. We'll find out more about them beginning right now. Inspired by the Northern Lights since the beginning of time, There's one that's traveled across the polar regions from one continent to the other. It comes up often among the peoples of the Arctic Circle, with slight variations. It says that the Northern Lights are a manifestation of our ancestors, or the gods, who are playing ball with a walrus skull. If you get your attention, they get agitated, and that makes the aurora more intense. This myth is well known to Northern peoples. When you whistle, you stir up the Northern Lights. But be careful, if these celestial players see you, they might want to tear your head off to have another ball to play with. So lower your head, whistle, and see if it's true.
I dare you take my life. I don't know. Northern Lights out.
Okay, let's come back down to Earth. We're on the roof of the Planetarium, near the foot of the Olympic Stadium Tower. Our ancestors may have created myths and legends to explain the aurora, but today we have science to unravel their mystery. How high up in the sky do you think the Northern Lights are located? Well, to size things up, Let's take a look at what's around us. Over there, the stadium tower rises 165 meters above us. In the sky, clouds form at different altitudes. The stratocumulus clouds we see above are 2,000 meters up. The higher we go, the thinner the air gets. Here at 4,000 meters, we could be at a mountain summit in the Rockies or in the Alps. Up here, it's getting harder to breathe. At 60,000 meters, where the atmosphere barely exists, sound doesn't travel, but the northern lights are produced even higher than that. The atmosphere doesn't come to a sudden stop. It grows less and less dense the farther we get from the ground. At an altitude of 100 kilometers, it's the Kármán line. We're officially in space. But there's still a bit of atmosphere left. It contains scattered atoms and molecules of hydrogen, nitrogen, and oxygen at very low pressure. It's not enough to breathe, but as we'll see, it's enough to play a role in creating the northern lights between 100 and 400 kilometers above the Earth. Seen from the ground, the blue sky seems immense, limitless. But seen from up here, we discovered that the atmosphere of our planet is a very thin layer of air between the infinity of space and the rocky material below us. So this is the Earth. Big ball of rock covered almost entirely with water. What you don't see from space is the important geological activity hidden beneath its surface. And it's there, buried deep at the heart of our planet, that we'll find one of the causes of the aurorae. Earth's interior is extremely hot. Various forms of volcanism bear witness. The heart of our planet is made up of two distinct parts. The inner core consists primarily of iron solidified by pressure. And the outer core, which also consists of iron, but in molten form, that churns around the inner core. It's a convection movement in the viscous iron outer core that generate a magnetic field. The magnetic field forms the basis of an immense shield that protects life on Earth from charged particles that come from space, the magnetosphere. Just like its core, the shape of the Earth is more or less spherical, but the magnetosphere surrounding it is not like that at all. Something disturbs it and affects its shape.